this is an agreement that I know I'm trying to motivate my students. The reason why I say this, and this is an agreement that is valid forever, is because you're going to see these situations in every class, almost every time. Maybe I shouldn't say 100%, 99% of our meetings will have something to do with this. So it is easier and better for all of us to know and understand this moving forward. Okay, it's not a big deal, but we have to make a little bit of effort. I don't know which classes you took before you came to this class. I'm not sure how the material was presented, but this is absolutely mandatory. This is the basics of everything we do here in this class and in math. So can anyone tell us what is A plus B? What is it called? It's like a foreign language, right? I would not be able to communicate with you if I didn't know how. It's the same thing here. So the terminology in math is important because otherwise we will talk about things that we will not understand what they mean. So we see here two terms, right? A term added to another term or subtracted. It doesn't matter. These are called terms, right? But because there are two terms, we have a specific name for two terms when we add or subtract two quantities. And the name is? Thank you. Antoine saved us today. Okay, so every time we have two quantities, in this case they're squared, so a term plus another term squared, a binomial squared, and this is also binomial squared. Anyone remembers what is the answer to this? Let's say we don't know, right? If we don't know, we will know from now on. So how do we square something like this? Don't be afraid to be wrong. We put them side by side, correct? And then we use correct. So here's another thing that I recommend. I carry a little note book like this one. And I write in here everything that I learned today. I learned today that I spilled my tea on the school's floor and I probably didn't tie it up correctly. No, I didn't write. I'm not going to write that, but that's a mental note for myself. So what I recommend is get a little note book, notepad, whatever you want, and write all the important information. Put the date of today and say, today, from moving forward, I will remember that the sum of two terms is called binomial. They can be added or subtracted because I didn't remember that. At some point in time, I knew it, but it went away. Then the next thing. Today I learned how to square binomial. And I put them side by side, and I will use FOIL. So please do that. If you do that every day, and put in here in this notebook everything that you learned, everything that is important. And I will say this is for notebook, but I will not be able to say it all the time. Some of you don't have to do it. They remember everything. Others may not have to write everything. They may write only about 50% of what we cover in class. But please do this. It will stick, and you will feel much better. Okay, so we are going to use FOIL, meaning we're going to distribute the first term to the last two, and the second term to the last two from the second binomial. Well, A times A. Perfect. A times B. Perfect. Plus B times A. Okay, or AB, the same thing. Plus B times B. Excellent. Good. But now we see that, what do we see? Correct. We have to combine like terms. These are two terms that are identical. So this is a squared plus 2ab plus b squared. So now we know the answer to a plus b everything squared. And we will not FOIL it again. You can if you want, but I want us to move forward. So if we want to move forward, we will have to remember that a plus b squared is
a squared plus 2ab plus b squared.
And moving forward, no one will ask, or if you do, it's fine, I'm going to answer anyway, but no one will ask, where does this 2 come from? By the way, where does the 2 come from? From combining two like terms. So now without foiling, because there is no more need, what will you tell me about a minus b squared?
A squared minus 2ab minus.
There is no minus on the last term. Very good point. There is no minus on the last term when we square a binomial. So here's what I recommend. Let's stop for a moment and look at 2 examples. And here's how I remember it, and here's how I recommend you remember it, the formula. It's a special product, basically. So let's say I have 2x minus 3y everything squared. And now you could say, okay, but I don't see your a and I don't see your b. Well, can anyone identify a? What is a?
X, 2x.
2x. What is b?
3y.
Exactly. So remember what this means. This is the first term. Is it the first term, a in a plus b? And then what b would be? What could be? Of course, the second term. So now, can anyone give us the formula thinking in terms of first term and second term, not a and b, because a can be anything like here, and b can be anything like 3y. So what do we do to the first term? Exactly. First term squared plus twice times first term, very good, times, very good, plus, exactly. So that's all you need to remember. First term squared plus 2 times the first times the second plus the second term squared. That's all it is. And now you will have no difficulties expanding this without foiling it. That's what we need. So can anyone square the first term? That's what the formula says. We have to square the first term. What do we get? Indeed, I wrote y. 4x squared. What is the sign for the middle term? If the middle term, if the binomial has minus in between, what will be the sign? Of course. Now, careful, this is what we want. We want 2 multiplied by 2 multiplied by 3, x and y. 2 multiplied by 2. How much?
4.
Multiplied by 3.
6y.
So 2 times 2 is 4. 4 times 3 is 12. 12xy plus
4
9.
9.
9y squared. So we need to practice this. It's not going to happen in 5 minutes, right? Any questions? Any questions? Okay, let's look at one more. 5x plus 3y squared. One other very important idea to remember is, and please write it down and remember it, put it on your notepad if you want, a binomial squared is what? What is the result? What is this? If this is a binomial, a plus b, what is this? A trinomial. Very good. Very good. A binomial squared is a trinomial, which means when we square, let's say, x minus y, you will never say x squared minus y squared, right? Why not? How come that I don't write x squared minus y squared? Is this a trinomial? Is this a trinomial? No, it's not a trinomial. So we can never write x squared minus y squared. That would be a binomial, correct? So then what would you write? X squared minus 2 times the first times the second plus y squared. So I was going to ask you to put your cell phones away. No cell phones in my class, please. Please. This is more important. Anything else can wait, unless it's an emergency. Okay? So coming back, can anyone give it a shot?
X squared plus 30xy.
So what do we write? First of all, first term squared. We cannot pick and choose. We have to square the entire term. So 25x squared. It is clearly it's positive because it's positive. 2 times 5 times 3. 2 times 5 is 10 times 3 is excellent. And then I have to copy x and y squared. And then plus 9y to the, so y squared can, yes, copy the base, multiply the exponents. Very good. So once you get the pattern and you understand the pattern, you can't see anything else. And I'm hoping that you're not going to do FOIL on the side. Is it wrong to FOIL? No. But the problem is when we get to factor. When we get to factor, you're not going to be able to FOIL, right? You have to go, we are going to be given this, and we have to come back with that. So that's why understanding the pattern is way more important than foiling it at this level. Okay, last one, and then we'll review the rest of factoring. I know we have only 13 minutes left. Okay, what about this? So remember, these are 3 special products, and we have an agreement on them. Moving forward, you will remember that a binomial squared is a trinomial, not just any trinomial, bless you. A squared plus 2, first term squared plus 2 times the first times the second plus the second term squared, or minus. And this is something different. Of course, it's not that. It's not this. So let's FOIL it once and for all. And let's see what we get. Anyone remembers what is a plus b times a minus b? Okay, so for the, yes, we're going to FOIL it, but this is something that we deal with a lot in the previous classes. But that's okay. That's why I'm reviewing everything. So a squared, and then a times negative b. Perfect. And then b times a. Perfect. And then b times negative b. Awesome. We see that this time those 2 terms are opposites. So when we combine them, they go away. So the answer is a squared minus b squared, which is, we call it difference of squares, which is a binomial. So moving forward, difference of squares, which is a binomial. So this is a squared minus b squared. So let's make a couple up. So let's say 2x minus 3y, and what is the other one, if we want to use this special product?
2x plus 3.
Very good, awesome. So then it has to be the difference of squares, and I have to square the first term, and what do I get? Perfect. Remember when We have plus and minus or minus and plus, it doesn't matter. This is a different, as long as they are identical except the signs in between. It has to be the difference, not the sum. So that's 9y squared. I strongly recommend please move away from foiling. We don't need it on special products. We have to foil on everything else. That is not a special product. Okay. Now I'd like to continue with 2 handouts. These 2 actually go together. Any questions for me? Any questions? Since we're not going to be able to finish this, tonight you do not have any homework other than getting on to My Labs Math or My Lab Math with a temporary code or not. The temporary code you purchase, whatever. It's up to you for now. So this is the only thing you have to do tonight. And when we finish this handout, then you are going to be able to access the homework and finish the homework on factoring extra exercises or something like that. There is a particular homework that I picked and I showed you when we accessed the website. Okay? So, okay, what is this? This is the factoring strategy that we will be using for anything we are asked to factor. That is either binomial or trinomial or polynomial. How many terms does a binomial have? How many terms does a trinomial have? Excellent. How many a polynomial? Or more. It can have 4, 5, 6, etc. But this is specifically for 2 terms. This is specifically for 3. And this is for anything that is not 2 or 3. Okay. So then, every time you throw a polynomial at me and say, here, factor it, here's my thinking process. I asked a lot of experts, there is a game that I play. It's not for money, it's not a gambling game. We can talk about it later. But I asked a lot of experts, tell me how you think. People who've been playing this game for 50 years. It's not me. So they will not really share. It's their baby, you know. They don't want to share the information. So I asked them, okay, you do this, and what is the first step? What goes through your mind the first time, the second level, third level, fourth level? They will never share that information. They will just throw something at you, but they will not really share. So that's very difficult to advance in a certain situation. So here I'm sharing with you every step that goes through my mind when you throw a polynomial at me and you say, factor it. So first of all, I'm asking myself, what type of polynomial is it? Because they're all polynomials. All these 3 are polynomials. This has a special name, this has a special name, and this is 4 or more. But they're all polynomials. So first I think in terms of, okay, which category is it? Because if it's a binomial, then I'm using these and not these. If it's a trinomial, then I'm using this slice. If it's a polynomial, I'm using this slice. They are completely separate. They have nothing to do with one with the other. Okay. So, except the top part. So first I'm asking myself, okay, what is it? Let's say it's a binomial. I'm asking myself, next step, is it in descending order? If not, I will rearrange it. Then, does it have a greatest common factor? If it does, I will pull it out. And then, does it have a negative leading coefficient? If it does, I will pull that out too. And then, since I picked a binomial, I'm going through these 4 special products. So that's the thinking process. Once you do it 15 times, then it becomes second nature, I hope. Some of you may need only twice. Some of you may need 30 times. But it will become second nature if you stay with it. So now, coming back to this handout, I separated factoring into 3 different categories, like I have it on this handout. It's right here, binomial, that's the top. Here's a trinomial. And here is a polynomial. Now, one more piece of information. Can I live without factoring? Yes, and very well. Yeah, so then why would I bother? Well, because if I know factoring, then I can understand other things faster. I can do my work faster. I can move on through math and understand, and a whole horizon opens up. You can say, just learn from this, yes. And you'll see, the more you spend on this, the better you get at it, and the easier everything else becomes. So this is not because I want to torture you and I want to, make sure that you know factoring. No, it will make your life easier. Okay? So let's start with the binomial. And then if we get to trinomial, we'll continue. So, but at least let's finish the binomial today. So, of course, I'm going to go through these steps. It's a descending order, greatest common factor, negative leading coefficient, and then the 4 special products. We do know one. Which of these 4 special products we just talked about? Is it number 1, is it number 2, 3, or 4?
Number 2.
We have not talked about the sum of squares. Sum of squares is not factorable. It's there because we need to talk about it. But this is the only one. The correct sentence is not, it's not factorable, to be exact. It's not factorable using integers, because we can factor it. But we're not really interested at this point in factoring that one, because it's not, we cannot factor using integers. Okay, yes, we discussed number 1. Can anyone give us the factored form of a squared minus b squared? Excellent. Indeed. A plus b times a minus b. Okay, let's practice the first one, and then we'll come back to the last 2 here. We just discussed that, right? Good, perfect. Okay, so we have a couple of questions here. Let's say the first one, 4z squared minus 25, and x to the 4th minus 81. The first 2 examples in that handout. Okay, so here's my thinking process again. I should also apologize to you that I will repeat myself. I will sound like a broken record many times, but in the hope that this will stick. Okay, it's a binomial. Is it in descending order? Yeah. The term with z and the term with no z, so it's in descending order. Greatest common factor? No. These 2 terms, 4z squared and 25, have nothing in common. Negative leading coefficient? No. The leading coefficient is 4. It's not negative. So now I'm here. Can I apply any of the special products? If it's this, which is not the case because it's not plus, I'll say not factorable. Now, is it this? Yes, it is. Because the first term, 4z squared, can be written like this. Is 25 a perfect square? Yes, because it can be written like this. So obviously, I have the first option, the difference of squares. Well, and I know how to factor the difference of squares. We just reviewed that. How do I factor it? Perfect. When we are asked to factor something, a polynomial, I meant to say, we're asked to factor it completely, till no factor can be further factored. So let's continue now with x to the 4th minus 81. I go quickly in my head through the strategy. What is it? It's a binomial. Is it in descending order? Yeah. does it have a greatest common factor? No. Actually, the fourth and 81 don't have a common factor. Is the leading coefficient negative? No, it isn't. So now I have to select if any of these is applicable. So is it a sum of squares? No, we haven't talked about the difference in this sum of cubes yet. So is it a sum of squares? No. Is it a difference of squares? I hope. I always hope for a special product. If it's a difference of squares, what squared is x to the fourth and what squared is 81? Excellent. So if this is x squared and this is 9, what will you say? Excellent. Now I'm asking myself, is this further factorable? And I'm going back to my strategy. The answer is no, because it's the sum of squares, correct? But what about x squared minus 9? I can apply the same property or special product again. So how will you factor this? Very good. And you have to copy x squared plus 9. This is fully factored. We cannot further factor this. And I'll have to stop. I have 3:15. My